Today's lesson is on dilations. After today, you will be able to understand that a two-dimensional figure is similar to another if the second can be obtained from the first by a dilation. You'll also be able to describe the effect of dilations on two-dimensional figures using coordinates. First, we'll look at our vocabulary. A dilation is a transformation in which a figure is made larger or smaller with respect to a point called the center of dilation. For our first example, we're identifying a dilation. Tell whether the blue figure is a dilation of the red figure. For A, lines connecting corresponding vertices meet at a point. So we have our two triangles, and you can see that the lines will meet at a point. So the blue figure is the dilation of the red figure. For B, the figures have the same size and shape. So the blue triangle and the red triangle have the same size and shape. The red figure slides to form the blue figure. So the blue figure is not a dilation of the red figure. It is a translation. Now we have an additional example. You can pause the video and try it on your own, or you may follow along. You're going to tell whether the blue figure is a dilation of the red figure and explain. For number 1, the blue figure would not be a dilation of the red figure because it would be a reflection. So no, the blue figure is a reflection of the red figure. And for number 2, yes, the blue figure is a dilation of the red figure because lines connecting corresponding vertices meet at a point. Now we're going to look at our key idea. In a dilation, the original figure and its image are similar. The ratio of the side lengths of the image to the corresponding side lengths of the original figure is the scale factor of the dilation. So for our key idea for dilations in the coordinate plane, to dilate a figure with respect to the origin, multiply the coordinates of each vertex by the scale factor k. So for our coordinate xy, we would have kx, ky. When k is greater than 1, the dilation is an enlargement, which means the image would be bigger. When k is greater than 0 and k is less than 1, the dilation is a reduction, which means that the image would be smaller. Now we'll look at our second example for dilating a figure. Draw the image of triangle ABC after dilation with a scale factor of 3. Identify the type of dilation. So we have our triangle. A is at 1, 3. So 1, 3. B is at 2, 3. 2, 3. And C is at 2, 1. So C would be 2, 1. So this is our original triangle. The red triangle is the original. We have a scale factor of 3, which means that we're going to multiply the x and the y both by 3. So for A, we have 3 times 1 for x and 3 times 3 for y. A prime would be 3, 9. For B, we have our original is at 2, 3. So we're going to multiply 3 times 2 for x and 3 times 3 for y. So B prime is at 6, 9. And for C, our original is at 2, 1. We're going to multiply 3 times 2 for x and 3 times 1 for y. So C prime would be 6, 3. So now we can go ahead and plot these 3 points. A prime is at 3, 9. B prime is at 6, 9. And C prime is at 6, 3. So the blue triangle is our image. The image is shown at the right. The dilation is an enlargement because the scale factor is greater than 1. And you can see from our triangles that the blue triangle, the image, is larger than the original. Now we have another example for dilating a figure. Draw the image of rectangle WXYZ after dilation with a scale factor of 5/10. Identify the type of dilation. So for our vertices of W, X, Y, Z, W is at -4, -6. So -4, -6. X is at -4, 8. So -4, 8. Y is at 4, 8. 4, 8. And Z is at 4, -6. 4, -6. Our scale factor is 5/10, so we're going to be multiplying the X and the Y both by 5/10. So for W, we have 5/10 times -4 for X and 5/10 times -6 for Y. So W prime is at -2, -3. X, we're going to multiply 5/10 times -4 for X and 5/10 times 8 for Y. So X prime is at -2, 4. For Y, we're going to multiply 5/10 times 4 for X and 5/10 times 8 for Y. So Y prime is at 2, 4. And for Z, we're going to multiply 5/10 times 4 for X and 5/10 times -6 for Y. So Z prime is at 2, -3. Now we can go ahead and plot these points. So W prime is at -2, -3. X prime is at -2, 4. Y prime is at 2, 4. And Z prime is at 2, -3. The image is shown at the right. The dilation is a reduction because the scale factor is greater than 0 and less than 1. So the blue rectangle was our image, and the red was the original. You can see that the image is smaller, so it's a reduction.